Hello, Techno Day. Thank you so much for joining me wherever you are in the world, whenever you are watching this. I'm so excited to get to share some of what I do every day with all of you. For those of you who don't know me, I work in IoT, and so I'm learning a bunch of new stuff in that field, and I really am excited to share some of the things that I'm learning about and kind of help everyone else get as excited about the Internet of Things as I am. So welcome to my presentation, MQTT Security, Tiny Protocol with Big Vulnerabilities. So a little bit about me. I am a principal security engineer for the Internet of Things. I have been working in security for about 20 years now. I have done just about any job in security you can possibly imagine, from incident response to tool development to now security of the Internet of Things. I am a United States Air Force veteran, so I spent 4 years on active duty. I also worked for NATO for a while, doing their security for their counterintelligence section. I also run a conference here in Seattle that's focused on women and non-binary hackers called DefendCon. So once we get back to the after times from coronavirus, hopefully we can meet together again in Seattle. It's usually a really good time. My hobbies include open source information gathering. I have another couple talks on that. I do a lot of photography. That's kind of my Zen disconnection hobby. And then I also raise a small child who has decided to never, ever sleep again because he's 2, and that's apparently what they do at this age. Quick disclaimer, the views expressed here do not necessarily represent the views of my employers or anybody that I work with or for. This is just me trying to teach you a little bit about some of the things I do day to day. All right, let's get started. So first of all, what is the Internet of Things? You see this term used a lot, and it's used to cover a lot of use cases and a lot of things, and there's a lot of gray areas. So you'll hear when you hear about botnets, well, baby cameras were hacked, or routers were hacked, or door locks were hacked. Well, all of those can be considered Internet of Things. Some of them live in the edge computing realm, but the basic definition of the Internet of Things is a network of physical devices. So the way that I think of this is if it can touch something, smell something, measure something, if it has a physical sensor, then it's part of the Internet of Things. This technology, as I'm sure you're aware, is exploding across the globe. Many of you, like me, probably have smart home devices. There's everything from light bulbs to dog trackers that are now on the internet. Your coffee machine's probably on the internet, your refrigerator. The use cases are honestly endless. And the technology right now is about $100 billion and is forecasted to grow to $1.6 trillion by 2025. So you can imagine that with all of these things out there, that's a lot of threat space to cover. And that's what I'd like to talk to you about today. So first of all, what is MQTT? So MQ Telemetry Transport, or Message Queuing Telemetry Transport, is basically just a standard communications protocol that's designed to be used for devices with small code footprint. It's a really tiny protocol, which makes it really ideal if you have a low-powered device that runs on a battery for 10 years out in the middle of a farmer's field, let's say. So it's really great for that. It's not as costly overhead as some of the other communication protocols. So its history is actually way back in the late 90s, they were trying to get information off oil rigs out in the ocean. And they had this problem that these really small, very thready connections to the mainland that were satellite links. And so they couldn't really get HTTP to work very well, and SMS didn't really work for their use case. And they kind of thought about it, and they created MQTT. But the problem was, they had a dedicated link between an oil rig and their backend factory. They weren't really concerned about the security of the information. They just needed the availability of the information. So security was never actually designed into the protocol, much like HTTP when it was originally created. There just wasn't the thought to put a bunch of security features in there. So the good things about MQTT is it's really scalable. You can connect hundreds of millions of devices to MQTT brokers, and you can do a bunch of cool things with the brokers, so they have failover and they have quality of service, and you're not going to drop packets. The packets are completely agnostic, which, if you can think about it like an envelope, I can just shove anything I want to in that envelope and send it to my camera or my door lock. It means I don't have to have a rigidly formatted packet with rigidly formatted data. I can kind of send anything I want, and that makes it really flexible. It's also really reliable. So unlike things that you might have heard like UDP, where it's really small, you can't ever guarantee that you got it, you can actually set quality of service rules on MQTT so that it'll keep trying to make sure those packets are delivered. It's also completely decoupled. It doesn't depend on the broker or the client to be connected at the same time. And this is really, really important in the Internet of Things because I can't always guarantee that my sensor out in Nigeria is going to be able to connect to the internet at the same time that my broker in California is also online. I need a way to make sure that if either one of them or both of them go offline, eventually that data will make it to where it needs to go. It's also super efficient, super low latency. It's designed to work on connections that are really lossy, connections that aren't very secure. This is the beauty of MQTT. Its entire purpose is to be lightweight and efficient. So before we talk about the security, I'd like to walk you through kind of how MQTT works in a normal setup. And there's a couple of variants and flavors, and this isn't true for all instances, but this is a very basic way that MQTT is set up. So the first thing you have is a publisher. Publisher is usually your devices. So think of your light bulbs in your house. Your light bulb says, "I'm on," and it publishes that message to the broker. And the broker goes, the light bulb is on. I've received this message, and I need to know if I need to send that message to any of the subscribers, like your iPhone app, for example, because your iPhone app wants to know that, yes, the light is on, so that if I need to turn it off, I can send a message back to say, nope, go turn off. So you have a broker that sits in the middle of that connection that then sends those packets onto a subscriber. And within all of this are topics. You can think of it kind of like a file system. So if you've ever used a Windows system or a Linux system and you have like a documents folder and you have documents/taxes or documents/home or documents/kids, it's kind of like that. A lot of times you'll have lights or sensors/lights or sensors/IR or some kind of grouping that makes logical sense so that when I send a message, I don't have to send it to each specific device on my network. I can tell all of the light bulbs to turn on. And that makes it really easy to sort of make sure everybody's on the same page and getting the same message. So here's a graphical representation of what that looks like. On the left is an IR sensor. This is actually based on one of my first IoT projects. It occurred to me that my poor cat, she usually joins me in these things once or twice. You might hear her try and break down the door here soon. My poor cat, her water dish is in our basement. So a lot of times, I know this is terrible, I will forget to refill it, and she usually reminds me. But I thought, wouldn't it be cool if I could just get an alert on my phone when her water dish got low? So I built an IR sensor that actually measures the level of water in her dish and publishes a small message to an app on my phone and says, "Hey, dummy, go refill the water dish." So it's kind of a very simple way you can think about this. And then in the bottom, you see a database, which if you're doing this at home, lightweight stuff like this, you probably don't need, but it's a good idea if you're getting a bigger installation. All right, so let's talk about use cases. The interesting thing about this, and what's funny to me, I mentioned before that I've been in security for about 20 years. And what's interesting to me is MQTT is one of those things where I can walk into a room of really, really sharp security professionals who are outside of IoT and go, "Tell me what you know about MQTT." And most of the responses will be, "What's an MQTT? What does that mean? I have no idea. I've never heard of it." And the thing is it's literally all around us. It's almost becoming as popular or as common to see as HTTP. So let's walk through some of the use cases where you might actually see this in your real life. All right, fancy cars, connected cars. I'm super excited about this, by the way. I am all hail the robot overlords. I'm all about self-driving vehicles. I think it's a super cool technology. Many of them run on MQTT, mainly because if you can think about it, if I am in my self-driving car and I'm out in the middle of the Nevada desert where Wi-Fi is not available, I can't have the car just stop working, right? I need to be able to have a technology that can store and forward and guarantee a quality of service. And that's why MQTT is really great for that. The thing with HTTP and SMS is they don't do really well if your connection can't be guaranteed. MQTT was legitimately built for that, so it's fantastic. So in this scenario, you can think of it as the car can publish to topics like speed or fuel level or oil life to a subscriber like your iPhone app or your manufacturer software. So in this case, if it's a sports car, maybe they have a predictive maintenance model where the car will say, hey, my oil hasn't been changed in a long time. You should probably remind my owner to go do that. And even fancier applications, it can self-schedule you for an oil appointment, so you don't have to worry about that. It's really, really cool if you think about it, but also it leads to some really interesting edge cases for security. We talked about the home automation example. This is probably where 90% of you are going to run into this in your day-to-day life. If you have an Alexa device or a Google Home device, if you have a smart light bulb or a smart lock, if you have any device connected to the Internet of Things, odds are really, really good it's using MQTT. And the funny thing is about this, you can actually run your own MQTT broker at home. Right now, most people just sort of go out and buy their IoT device and slap it on the network, and sort of what happens in the background is invisible. And it works, and it's a really good use case, but it can also be really fun if you just want to have an Internet of Things in your own home that doesn't connect to the outside. You can do this completely self-contained to your own network. Industrial IoT. This is where it gets really interesting. So if you can think about connected factories, and up at the top, I have this soldering machine that's soldering chips onto a board. You can imagine something like a giant robot that moves packages in a warehouse, or a robot that does car manufacturing. Imagine if those messages were to get interrupted or subverted or taken over. You can imagine that that would be a really unfortunate use case. And all of this is powered by MQTT in many instances. All right, so let's talk about the types of attacks that we can see in MQTT. So the good thing about MQTT is that it has a centralized broker. The bad thing about MQTT is that it has a centralized broker. And the reason that can be bad is because, just like anything, if you are familiar with sort of the old hub and spoke model networks, the number one thing you learned, and I know that dates me quite a bit, is that if the central switch goes down, everything goes down. Well, the same thing happens in MQTT. If I can seize all the connections on the broker, so if I can just send a bunch of requests, say, hey, I want to subscribe, I want to subscribe, I want to subscribe, the MQTT broker gets overwhelmed and it just barfs, and then it can't do anything. It also, we can just send it and tell it, no, I'm really the light bulb. Not that other guy. I'm a light bulb. And it's designed to drop duplicate client IDs. So I can actually just take out legitimate client IDs by pretending to be them. There's also really poor auth-in. And what I mean by that is that most of the out-of-the-box setups have default clear text credentials. There's no encryption. There's no auth required when you make most of these brokers. Like, default comes just no password. And if there's any security, it's usually just username and password, which is almost always really terrible. It's almost always something like admin, or something really easily guessable. It's not very complex. It's just out of the box, not designed to be secure. It also has really poor auth-z. And I say this on both sides of the coin because, done well, MQTT actually supports really strong auth-z. You can have a per topic device for every single device in your home or in your network and have very limited scope, but that becomes really hard to manage. I don't want to have to think about, well, should my iPhone app be able to publish to my front door light bulb or just my back door light bulb, or both of them at the same time? Is that a different topic? So what happens is most manufacturers just kind of do the easy thing and say, just let them subscribe to everything. It's too much work to separate it out. Just basically, if you can think of it like a file system, just give them, splat. It'll just let them jump to everything. And that can cause a lot of problems. Like I mentioned, the broker is just a software application, and many times just a Java software application. Like any software, it's vulnerable to attack. There's multiple CVEs out against the most popular and common brokers. Many of these installations never get patched or very rarely get patched. And so it's very easy to get remote code execution on an MQTT browser. And then not only am I affecting the devices and clients that are in my network, if I share that broker with another service, I could potentially be affecting them too. And then there's transport security. So we mentioned that most of the credentials are in clear text. This protocol can use TLS, and it's very important to try and use TLS and device certificates, but most people just don't because it is really hard to implement and really hard to architect. All right, so we talked about this. If I want to take out your broker, basically all I have to do is be really noisy and make the broker work really hard so that it doesn't have time to talk to anybody else. I don't even have to make it fail ungracefully. I just have to make it so busy that it can't actually deliver the messages that I need it to get to. So if you can think of this in a factory floor, and let's say I have a metal crushing machine in the factory floor, and the metal crushing machine senses that it's too full and it needs to stop. So it connects to the broker and is like, hey, I'm too full. I need to stop. And the broker's like, yeah, that's cool, but I'm really busy dealing with all this other stuff. That message is never going to get through, and that can have real world consequences. I can also just send a bunch of malformed packets. I mentioned before that the packets are agnostic. I can shove anything I want in there. But at a certain point, when I start shoving things, it starts trying to unpack them and goes, what is this? I don't know what to do with this. Oh gosh, okay, and it stops. So it's really easy to overwhelm the central broker. We talked a little bit about poor authentication. Most of the usernames and client IDs that I see are really easily guessable. They're lightbulb 1, lightbulb 2, lightbulb 3574, or they're based on the MAC address or the serial number that was printed from the factory. Even where I do see things that use per device certificates, they use per device certificates that are replicated over a batch of devices. So if you can think of a semiconductor factory that's churning out chips, they may only use it for the first million chips, and then they'll rotate it and use it for the next million chips, but that's still a million devices with the same certificate, and that's not really great. Poor authorization. We talked a little bit about this, right? It's just really, really hard. Imagine back in the days, if any of you had the misfortune of running old Windows networks where you had to grant permissions on a per file basis. It was a nightmare. It was an absolute nightmare. They don't have this concept like we do in most modern operating systems where you can do, sort of role-based architecture and say, okay, well, all my light bulbs are technically sensors, so they should have everything under sensors. A lot of it's just very, very hard to implement. And so they make it easy because in IoT, availability is really a lot more important than a lot of security. So most of them support wildcards where you just say, I want to publish to sensor hash. So everything in sensors. It kind of makes it really easy to work with and really easy to attack. All right. Talked a little bit about software vulnerabilities. Just like any software, it runs on a computer. It has people who code it. Those people are humans and they make mistakes. And that software has vulnerabilities. If I can get the broker to run as root on the machine, now I can do anything I want with the data and traffic that's coming through there. It's surprisingly not that difficult when you start looking at these old installations of MQTT brokers that haven't been patched to actually take over that broker service and sit in the middle of hundreds of thousands, if not millions of devices and consume their data. It doesn't support encryption natively. You can add it on with TLS or SSL. But a lot of these devices, because they're so lightweight and so low footprint, even when they do support cryptography, it's usually really bad cryptography because they just don't have the overhead capacity to do that really heavyweight cryptographic protocol stuff. So those lightweight implementations of cryptographic protocols often have vulnerabilities in them that make them really easy to attack. Also, the certificates that are issued are usually smaller than you normally find in your traditional web applications. So they don't have a lot of entropy. That means they're not very different from each other. So once I find enough certificates, I can start to calculate the similarity in data, and then I can try and break all the other certificates next to it. So what's the problem? I mean, who really cares about this, right? Well, if any of you have done security, you might have heard of a tool called Shodan. And the interesting and terrifying thing about Shodan is it allows you to scan the internet for IoT devices. And if we modify that, we can listen for MQTT without SSL, so unauthenticated, unencrypted MQTT, on port 1883. And then we can try and attempt to connect to the sys broker. And the sys broker is basically MQTT's way of saying, hi, I'm here and I'm ready to talk. So this was a scan I did last year. It doesn't change much. I've tracked these for a couple years now, and it tends to sit right between 35 and 45,000 devices. But you can see like China and the United States, there's just a ton of open brokers. And if you think of this, these aren't devices, these are brokers. So 9,000 brokers, if each one of them had 100 devices connect to it, that's a lot of data and a lot of surface area to attack. And you'll find that these things are sometimes really lame. Like there's one that I saw in the Ukraine that's a IP camera that watches a junkyard. Don't know that anyone really cares super much about that. But then there's some where they're in power plants and, they're in factory floors. And those I actually do really care about. And those I really, really, really hope are not exposed to the internet with no authentication. So now that I have this information, what can I do with it? So Shodan has a great paid subscription feature, and they didn't do their Black Friday sale this year, and I'm super bummed. So I didn't actually get a subscription this year. And I didn't want to pay for one out of pocket. And since this technically is not my day job, I don't actually need it for my job. So I got to thinking, well, how can I replicate this? And so I found this tool called Masscan. And this is a lot of fun. For those of you who have used Nmap at all, the syntax is really, really familiar. It's just a scanner, but it's like a scanner on steroids. It can scan the whole internet in a matter of minutes, depending on your connection, obviously. So I decided to use it to find open brokers. The tool is published by Robert David Graham, and you can actually go download it from GitHub. I threw it up in a cloud instance on Linux, and it just worked. It's super easy to use. If you've used Nmap at all, the syntax is almost identical. Even if you haven't used Nmap, I highly recommend playing around with this tool because it's just so much fun. But with that comes the shame disclaimer. So the interesting thing about subnetting, and to do Masscan, you'll need to learn a little bit about subnetting, is that if you make a minor typo, sometimes you can scan a lot more than you think you're scanning. So for example, hypothetically speaking, if you worked at a large company and you had a range of like 65,000 devices you were going to scan, but you weren't paying attention and you accidentally shifted right, you might scan a couple million devices on the internet in Illinois that don't belong to you. So you don't want to do that because that's not good. Some parts of the internet don't really love being scanned. If any of you followed the US elections this year, you'll notice a lot of sort of false flags that came up around the Internet of Things and voting machines and, oh, this thing connected to the internet and it's a voting machine. And, those are 99% false flags, but you also have to think, if I was able to scan a voting machine, that's probably something that DHS and FBI would want to talk to me about. So I don't want to just go randomly scanning the internet on the off chance I kick a hornet's nest. So just be very mindful of where you're scanning. Remember, you should have permission to scan things. I know that's a bit contentious in our community, but legally, ethically, you should probably get permission before you go scan things. So this is a snippet of the syntax. I won't go into it too deep because it's, like I said, if you've used Nmap, it's pretty similar. And plus, honestly, most of the time I just copy and paste from old commands because I'm lazy and I don't memorize syntax. So I ended up scanning about 16 million hosts. Whoops. And so I scanned on both 1883 and 8883, so both the encrypted side and the non-encrypted side, just to kind of get a space feel difference for who was running encryption and who wasn't, and sort of what my actual threat vectors look like. So I got 225,000 hosts that were alive. So remember, this represents brokers, so not individual devices. And then I got 2,500 roughly hosts with either port open. And then from that, I funneled down to roughly 1,000 hosts with 1883 open. And the reason this is important is because if I'm doing a pen test, for example, if I'm doing an engagement and I'm auditing this, I have a limited time. I don't want to make my life harder than it needs to be. So if I can find an MQTT broker that's running on 1883 with no encryption, that's a lot easier to attack than somebody who's running TLS, double-sided authentication. Like, that's just a lot easier for me to attack. So I'm lazy and I like to find easy open doors. All right. So now what? So now I have a list of brokers that are talking to me on this port. It's a good chance that they're probably MQTT brokers. Not necessarily. Sometimes people do weird stuff and it squawks back on a weird port, but maybe, probably. So now I have to see if I can connect to it. Sorry. I've actually had a super big respiratory infection, so I may actually completely peter out of voice at the end of this. So now what I want to do is I want to use some way to connect to it. So I use Paho. It's pretty common. It's a lightweight MQTT package. And I start scanning these hosts, and it's just a little script in Python. And basically it just says, hey, how are you? What you doing? Very common to like HTTP connections. I get a 0 return code. That means the broker saw me and it says, way to go, I'm connected, welcome, come on in. Number 1 is kind of interesting. It refused me because I'm not using the right protocol version. So that's not a no, that's just a not now. 2 is interesting too. My identifier was rejected. So maybe I need to do some work in figuring out what the client ID schema looks like. So again, not a no, just a not right now. Number 3 is a little less interesting to me. It means the server's unavailable. Depending on the type of engagement I'm having, I might go back to it, but I could wait for years for that broker to come back online, so I'm not super jazzed about that. 4 can be interesting because it means that the host is alive, and it's alive enough to know that I have the wrong username or password. And number 5 is less interesting because it means they're probably doing some kind of IP filtering, or they're doing something that means they're just not going to accept my connection without a whole lot more work. So I don't really want to mess with that. So my best bet is connection 0 accepted. And that's when you get really excited. So then I pivot over to a tool called MQTT Pwn. It's this amazing, awesome, phenomenally designed tool by Akamai, completely free. It comes in its own little Docker container. This thing is the Swiss Army knife of MQTT, and it's phenomenal. And plus, I'm one of those people. I don't build tools. I use other people's tools because again, I'm a little bit lazy, and I really like it when people do amazing things and then release them open source. It just makes my heart happy. So MQTT is great because it allows me to do brute force credentialing. So that connection code that I got earlier that said connection refused, bad username and password, I can just start throwing passwords at it. I was talking to an engineer in my team, and he said, yeah, I was trying to debug one of my light switches, and I won't use the company name, but I couldn't get in, and so I rainbow tabled it, and the password was manufacturer name 1. And these are usually not that good, even if they do have a password. So brute force credentialing and rainbow tables are often really successful. I can also start to do topic enumeration for the MQTT brokers that said, welcome, connection code 0, come on in. I can ask them, so hey, what do you do here? And if I start getting things like, well, my topics are nuclear power start, nuclear power stop, nuclear power meltdown, that could be really interesting to me. For the record, I have not found a nuclear power plant that is set up like that, nor do I expect to. But you can kind of, people name things in a way to make them familiar. So it gives you a lot of information about the types of devices and applications that are in the brokers that you're connecting to. It can also help you do just reconnaissance, basic reconnaissance, and see what's connected and, who's doing what and who's sending messages and how many messages are sent per second, per hour, per day. I can get a lot of information about how active this is. And that can be really interesting if I'm trying to stage an attack, because if I'm going into a really secure implementation, which I would argue that if they're unauthenticated, they're not really that secure, but benefit of the doubt, it's an oversight. And maybe they're doing some monitoring. Maybe I want to stay below a certain threshold. Many tools that monitor these things go, okay, this device sends 5 packets every hour. And it's cool until I send 500 packets in an hour. And then it's like, whoa, something's wrong. So having that information allows me to kind of creep in low and slow and stay within the bounds of the normal system operation. All right, so This was kind of a very generic, I didn't want to put anything out there. It was terribly crushing to anyone. So this is just kind of a dump of a kind of easy one. And it kind of lets you know like which sockets connect 1, 5, 15 minutes, the load, how many bytes were sent, how many bytes received. If you went down, I think this entire list was like 200 topics. And they had light bulbs and they had some cameras. I think this was some sort of like, wasn't a factory. It looked like some kind of manufacturing yard. Based on the cameras and stuff that I was able to see. So kind of a very basic implementation. But it kind of lets you see what they do and it sets the stage for what I can actually access. So by now, you should be looking around and going, wow, MQTT is everywhere, and I am terrified to my very soul because it's in industrial factories, and it's controlling all the light bulbs in my house, and these are real-world use cases that should keep me up at night. And I could talk to you about all of those, and we could all get really, really bummed out. But I would like to talk to you about something a little bit more interesting. I would like to talk to you about breaking the Internet of Cows. Remember when I said the MQTT and IoT were everywhere? I don't know if you know, but I do mean everywhere. We have internet-connected cows now. They have sensors in their stomachs to see if they're digesting their food properly. They have sensors under their tail to see if they might be going into labor. This particular application is a cattle driving system that's like a collar, like a dog collar, but for cows. And it does geofencing and sort of offhand ranching. So if you can think about it, the cow wears this collar. The collar is geo-aware, so it knows where they're supposed to be and not be. And if the cow wanders too close to the virtual fence, it gets a little nudge and it goes back to its, grazing land. All of these operate on MQTT. All of these operate using a centralized MQTT broker that can fall over. They also operate on very teeny tiny devices that have very low security. So if you can think about compromising this MQTT broker for this fairly ridiculous use case, now I have 100 cows roaming the heartlands of America that are doing my bidding. And you can imagine running them through a town, running them through a store. I mean, that could be potentially really funny, but also really disastrous. And it just kind of goes to show that even if you're not aware of it, this protocol is everywhere. And so it's something we really should be talking about. That means we can make the internet of zombie cows. And if I do nothing else with my time here on Earth, I would like to be known for that. All right, the good news. Many applications are moving into the cloud. That's great because it means that many cloud instances have a lot of baked in security that you just don't get if you're kind of rolling your own. So, if you go to the major cloud manufacturers, you have to use TLS by default. They won't let you connect unless you do. They're able to connect and see if you're using duplicate credentials. They're able to monitor some of your cloud side configurations and tell you when things are going wrong. There's an easier way to do device policy and authentication because oftentimes you can piggyback off commonly enforced industry standards. And they have the framework all set up for you. So you just kind of need to bring your device and it's all there. And everyone knows that once it's in the cloud, you don't have to worry about it. I'm kidding. That's totally a lie. You should absolutely worry about it. The cloud is really good because it's really configurable and has a lot of great default options. But it also makes it really easy to do really dumb things at a really big scale. The more devices that connect, the more dependent we become on shared broker services, on shared connection services. So now that, it's not just the internet of zombie cows, it's the internet of zombie cows and my robot vacuum cleaner. So you can imagine that with every use case, these dependencies get more and more and more intertwined. And so it's really incumbent upon the person putting their devices into the cloud to make sure they're doing the right things with the tools they've been given. A lot of times these systems, even though they're on the cloud, which is highly redundant and highly available, aren't actually designed that well for redundancy because you're talking to people who have had a factory in Oklahoma for the last 10 years who just don't do this, right? That's not their job. They don't think in terms of what if, this factory goes out, or what if we have a hurricane or a tornado and maybe I should configure my availability zones to be different. So this is a learning curve for a lot of people who are bringing these legacy operations into the cloud. And we as practitioners need to do a better job at making it easy for them. All right, that was a lot of information, and I hope it kind of opened your eyes to some of the use cases around you that you may not have already known about. But here's the things I hope you take away from this. MQTT, lightweight, widely adopted protocol used for IoT, publish and subscribe. If you take away nothing else from this talk, that is the thing you should take away. The other thing that you should take away is that it's often insecure and often misconfigured. Many times there's no authentication. You really have to watch when you're deploying that you use encryption, because otherwise your username and passwords just aren't going to cut it. And also have tightly controlled device certificates, and per device ACLs is the most crucial thing you can do to make sure you have a secure instance. I hope you guys had fun. Thank you so much for joining me. For those of you who want to learn more, I have a really terrible, crummy website that you can check out that I keep meaning to make better, but it is what it is. That's the link to the Masscan tool and the MQTT Pwn tool that I use. For those of you who are at home thinking, wow, this is great, but I feel like maybe I jumped about 3 steps ahead. I don't know anything about the Internet of Things. I don't even know what that means. There's this great link to an Instructables on building your own Internet of Things, and it's super valuable for those who just want to start getting their feet wet, even outside of a security context. I thought it was really helpful and really well written. You can follow me on Twitter. That's my Twitter handle. That's pretty much everything I have for this talk. Thank you so much for joining me, and thank you to Techno Day for having me. It's been the highlight of the pandemic to be able to virtually speak to a lot more people than maybe I wouldn't have been able to before. So thank you so much for having me, and I look forward to seeing you out there. Bye.